day, everyone. My name is Mr. Hosea Yakubu. You're welcome to another session of Mathematics for the African Child. Today we're going to, prove the sine rule. The sine rule actually states that A sine A is equal to B sine B being equal to C sine C. So we want to prove that. You know that this is a sine of an angle in a given triangle. Similarly, this is a sine of another angle in the same triangle, and this is a sine of another angle in the same triangle. This is the side of the triangle. A side in the triangle. This is another side in the triangle. This is another side in the triangle. So side A over sine of the angle A is equal to side B over sine of the angle B, being equal to side C over sine of the angle C. So we want to prove that now. Suppose you are given a triangle like this, and you nickname it angle A, B, C. We naturally know that this side is side B, this side is side A, this side is side small letter C. So we want to actually prove this triangle is not a right angle triangle. We can easily do some constructions that will help us. So I will do the construction by bisecting this angle to create a perpendicular line to a point, let's say D. Then I'll also bisect this angle, angle C, to create a perpendicular here to a point, let's say capital letter G. Is that? Now we all know that this side is side C, this side is side B, and this side is side A. So you see, for every perpendicular there is a right angle. If you look at it very well, we have created two right angle triangles. That is, we have right angle. We have a right angle triangle. See the way I will write my right angle triangle. I have my right angle triangle ABD. That's A, B, D. And I also have another right angle triangle. This is D. D. And I also have another right angle triangle. I also have another right angle triangle ADC. ADC. So, are we there? Very interesting. So when we look at it very well, we can actually do one or two things there. That's on this side we have two. Then on this other side we also have some other right angle triangles. We have a right angle triangle AGC. Right angle triangle AGC. Then we also have another right angle triangle CGB. Another right angle triangle CGB. Okay, so now, if we are dealing with this right angle triangle, the sine of this angle C sine angle C will be equal to, sine angle C will be equal to opposite, that is AD over hypotenuse. Over hypotenuse, that will be AC. Is that? Then when we take the sine of this angle, when we take the sine of this angle, that's sine B will be equal to now AD over AB. That will now be AD over AB. But we know that, we now say but AC here, AC is B, and AB is A. When we substitute, let me substitute. We now say but AC is equal to B, and AB is equal to what? Is equal to C. So let's substitute it into this. It now means that sine C will be equal to AD over, what is our AC? Our AC is B. By the time we cross multiply, AD will be equal to B sine C. We call this one, let me call this one equation 1. Then if you substitute AB here, which is C, we'll end up having sine B. Sine B will be equal to AD over C, which implies that, let me do it here. I, is that? That will now give us AD will be equal to C sine B. Since this is AD and this is AD, it means that AD is equal to AD. It implies that, it implies that C sine B is equal to what? B sine C. Then you can now see mathematically that it is the same thing as C over sine C being equal to B over sine capital letter B. We've gotten one part of this. This is one part of our solution. Then let's go down. What we considered was this right angle triangle and this right angle triangle. Let's take the other right angle triangle. That's this other ones and this one. So let me do that. That's what we are looking at is what? Is AGC. If you look at AGC, we can take sine A. We now say sine A will be equal to sine A. Sine of this angle will be equal to opposite over hypotenuse. That will now be GC or CG over AC. That will now be CG over AC. Is that? Then, if you also take this, looking at this, if you take the sine of this, that will now be sine B will be equal to GC over BC. That will now be CG over BC. Then from this point, you now say but AC, where's our AC? AC is equal to B, and BC is equal to what? What is our BC? Is equal to small letter A. Now, we can simply substitute. When we substitute, that implies that sine A will be equal to CG over, what is our AC? Our AC is B. When you cross multiply, CG will be equal to B sine A. Is that? Similarly, when you cross multiply the second value, or substitute BC, that will give you sine B will be equal to CG over, what is our BC? Our BC is A. When you cross multiply, that means that CG will be equal to what? Will be equal to A sine capital letter B. Then from here now, we will now, since CG is equal to CG, that means that B sine A is equal to A sine B. Therefore, B over sine B will be equal to A over sine A. Then we're able to, since A over sine A is equal to B over sine B, and C over sine C is equal to B over sine B, which means that A over sine A will be equal to B over sine B and will be equal to C over sine C. Therefore, you now say thus. That's our conclusion indicator. Thus, A over sine A will be equal to B over sine B will be equal to C over sine C. Hence, this is the proof. Thank you. If you like my video, you subscribe and click on the notification button.